In this lesson, we're going to learn how to solve rational equations, and this is going to be part 1. Now, keep in mind that in previous lessons, in previous semesters, you've learned how to solve linear equations. Okay, linear equations. And you had equations like this, 2 minus 3 times x plus 1 equal 4 times x plus 2 minus 7x, let's say. All right, so you solve something like this, and that was a linear equation. Okay. You've also learned how to solve a quadratic equation, and the ones that you've solved at this point, though, were quadratic equations that were factorable. Okay, they were factorable. All right, so when we solve some of these rational equations, you're going to see that at some point you're going to end up with a quadratic equation, and these quadratic equations will be factorable. And an example of a quadratic equation that you solved was, let's say, something like this. Two x squared plus 5x minus 12 equals 0. Okay, now at each point when we actually do part 1, you're going to see we're going to do these again. It'll be part of this process. All right, but the point being that in order to be able to solve rational equations, you have to remember how to solve a linear equation that looks like this, and how to solve a quadratic equation by factoring that looks like this. Okay, so those are two important prerequisites for part 1. All right, so now again, you should have mastered these by now. But if you still have a little bit of issues, hopefully as we go through part 1, the concept of solving a linear equation and a quadratic equation by factoring will be a little bit better for you. Okay, so we're going to start with some examples of rational equations. Okay, so here are examples of rational equations. And we're going to talk about what makes this a rational equation. All right, so the first one would be something that looks like this. Let's say we had x divided by 5 plus 2/3 equals 7/2, let's say. That's a rational equation. Now, a rational equation is an equation whose terms are rational, so you have rational terms involved. Now remember, a rational number is any number that can be written like this, like a fraction, a over b, such as example would be 7/5. All right. 3 would be a rational number because 3 can be written as 3 over 1 or 6 over 2, and so on. Okay, so there's an infinite ways of writing 3. But the important part here is this. So you notice that this term is a rational term. You have a monomial divided by a monomial in this case. Okay, so notice that these are monomials. One term. 2/3 is a rational term. You have something that looks like a fraction. Okay, this is a rational term. You have something that looks like a fraction. Now, there's a more specific definition of rational equation, but I'm making this more general. So just for right now, just look at this and see that, hey, I have a fraction, I have a fraction, I have a fraction, and it didn't have to even look like these. For example, I could have had, let's say, x down here plus 2x divided by 3, well, let's say 2x minus 1 divided by 3x equals 6. So the point being here that, see, this 6 doesn't look like a fraction, but it really is a rational expression because I can write this as 6 over 1. And notice that this numerator here is not a monomial. It's a binomial. All right, so this is a monomial, this is a monomial, this is a binomial. All right, so they don't always have to be monomials, your numerator or denominator. You could also have an example that looks like this. So let's say we had, and again I'm making this up, 3x minus 1 divided by x plus 2 minus 7 divided by x squared minus 4, let's say, equal 6 divided by x. So you could have something that looks like this. All right, but all of those are rational equations. You have terms. Each term is a rational expression. Okay. Now, keep in mind though that in order for these to be rational, though, and it'll be in this lesson and in all the lessons that pertain to rational equations, the exponents have to be whole numbers. So you won't see any of them being like x to the negative second. All right, so they all be positive whole numbers. Okay, positive numbers. So you see like x to the first, x squared, x to the first, x first, x, and so on. Okay, so the exponents are positive numbers. Now I need to be a little bit careful because 7/5 is a positive number. So let's just say whole numbers. Okay, they're whole numbers. So remember, your whole numbers are something like 0, 1, 2, 3, 4, and so on. Those are your whole numbers. Okay? All right. Now, what we're going to do now is start solving these rational equations. So let's look at some examples. Okay, the first one. Suppose we had 2/3 x minus 5/6 equals 3/4. All right, now in part one, we're going to look at rational equations where the denominators are monomials. Okay? So the denominators are monomials. So meaning you have one term in the denominator. See, like 3, 6, 4. This is not a monomial. That's a binomial. Okay? This is a binomial, and so on. That's a monomial. This is a monomial. Monomial. I can write 6 as 6 over 1. 1 would be a monomial. Monomial, monomial, monomial. Notice I'm using the word monomial. All right, so in this lesson, we're going to be focusing only on those equations that have denominators which are monomials. Okay. Now, it's important that when you look at a rational equation, you ask yourself, let's look at the denominators. If they're monomials, I'm in good shape. That's the easy kind. Okay? So for example, this would be an easy kind. This would be an easy kind to deal with. This would not, because these are not monomial factors. So you have to do a little bit of other stuff to it. Okay? We'll get to that in some other parts. All right, but for part one, we're only going to be dealing with denominators that are monomial factors. All right, so if that's the case, the first thing you want to do is this. Step one. You want to find the LCD. Find the LCD. So the least common denominator. So if you look at all of your denominators, my denominators are 3, 6, 4. You ask yourself, what's the least? What's the smallest factor? What's the smallest common multiple that 3, 6, and 4 goes into? What's the smallest number that 3, 6, and 4 go into evenly? Okay, so if you look at 3, 6, and 4, I would always start with the largest number you see. Okay, so let's look at multiples of 6. 6. Will 3 go into 6 evenly? Yes. Will 4 go into 6 evenly? No. So let's look at the next multiple of 6. 6 times 2 is 12. Will 3 go into 12 evenly? Yes. Will 6 go into 12 evenly? Yes. Will 4 go into 12 evenly? Yes. So the least common denominator is 12. So in this case, the LCD is 12. Okay? Not 6, not 4, not 3. Because if you said 6, 4 doesn't go into 6 evenly. All right? So it's 12. So again, look at when you're dealing with monomial factors, denominators, terms, look at the largest that you see and look at the multiples. 6 times 1 is 6. 6 is not the least common denominator because 4 doesn't go into 6 evenly. 6 times 2 is 12. 12 will be the least now because 3 goes into 12 evenly, 6 goes into 12 evenly, 4 goes into 12 evenly. Now remember, it's always a good idea to use the least. So if someone said, could I use 24 as my common denominator? Now it's not the least, but is a common denominator. Yeah, you could use 24. I would not. But using the least will make things a lot easier for you. So always look for the least. All right, now here's the next step. Step 2. Step 2 then is to this. Remember, the whole idea when solving rational equations, you want these denominators to be ones. Okay? You want these to end up looking like this because you've had experience solving this kind of equation. You've had experience solving this kind of equation. Okay? So basically, you're going to clear the denominators, basically. So you can clear denominators. Now you're going to clear the denominators by doing this. Multiply both sides. Multiply both sides of the equation. Multiply both sides of the equation by the LCD. Okay, now here's basically what's happening. Okay, so this is going to be important. You really need to write this down. That would be your next step. Once you find the LCD, your next step is this. So do you see that on the left side you have two rational terms or two rational expressions or two fractions, right? And on this side, how many do you see? You see one. Whenever there's more than one, like in this case, there are two, you're going to put the left side in parentheses. So you're going to say 2/3 x minus 5/6 in parentheses. All right, now remember the next step is to multiply both sides by the LCD. So now you're going to say, all right, I put this in parentheses, now I'm going to multiply it by 12. But again, what you do to one side, you do to the other. So then I go to the other side and I also multiply by 12. Notice I didn't put this in parentheses because it was not necessary. You just have one fraction. Okay? All right, so that's where I'm at. All right, now here's the next step. So just as you did before, so remember when we did this right here? I'm going to go ahead and rewrite this. So we had 2 minus 3 times x plus 1 equals 4 times x plus 2 minus 7x. So remember when we did this, what was the next step you had to do? Well, if you said get rid of the parentheses by using the distributive property, you were right. So you had to use the distributive property. Okay, so same thing here now. So you see I have parentheses, so now I'm going to use the distributive property. Okay? All right, now listen carefully. This is how you're going to write this. It's important you do this step by step because solving these rational equations, I'll be honest with you, is for many students, it's a little troublesome. All right, but if you do it step by step, you should be okay. All right, so step by step. All right, so now look at the next thing you would write. Write this out. Say, okay, so that would be 12 times 2/3 x minus 12 times 5/6 equals, and then 3/4 times 12. All right, so the first thing, all I wanted to do here in this little part was get rid of the parentheses. Okay, so I cleared the denominators, so I'm going to clear the denominators by multiplying both sides of the equation by the LCD. Okay, so then let's go ahead and reduce this as much as possible. All right, so remember, though, that 12 times 2/3. Remember, the whole point of multiplying by the LCD is to make this no longer a 3, but to make it what number? Do you remember what we said? A 1. Make that a 1. The whole point of multiplying both sides by the LCD is so that way this will be what number? A 1. And this will be what number? 1. Okay? And it will be. Because watch. See right here I have 12 times 2/3. Well, it's really 12 times 2/3 x, but I'm just going to look at the 12 and the 2/3 first. So when I reduce this, you got to remember how to reduce. So I'm going to write this as 12 over 1. 3 into 3 is 1, so I get a factor of 1. And then 3 into 12 is 4. So this becomes 4 times 2, which is 8. So 12 times 2/3 x becomes 8x. So you see, you no longer have a fraction. And at some point, it's going to look like this equation. It will look like this. Okay? All right, let's go to the next one. All right, minus. All right, and you could do this part here. So remember, the whole point of multiplying by the LCD is to make this a factor 1. So you better make sure that 6 goes into your LCD. That's why we used a common denominator. And it's always easiest to use the least. So 6 into 6 is 1, 6 into 12 is 2, and what's 2 times 5? 10. So I get 8x minus 10 equal. You're almost done. 4 into 4 is 1, 4 into 12 is 3, 3 times 3 is 9. All right, so look at what we have so far. Okay, so step 1 was to find the LCD. Now again, remember this is the easy kind because my denominators are monomials. 3, 6, 4. They're monomials. So then, once you find the LCD, the next step is you want to clear. See how I cleared the denominators? So you want to clear the denominators by multiplying both sides by the LCD. Now the reason why I use parentheses, you got to remember why. Since I use the reason why I use parentheses is because this side had more than one fraction, and so you need parentheses there. And then we distribute, and then we remembered some skills of what to do when multiplying fractions. All right. Now look at what I have. I have this linear equation. So to solve this linear equation, this is the easy kind. I'm just going to add 10 to both sides. So remember, to solve a linear equation, you bring all constants to one side, variables to the other. And so when I combine like terms, this is 0. So I'm left with 8x equal, and this is 19. And so I get, to get x by itself, I'm going to divide both sides by 8. And so I get x to be 19 over 8. So that's your solution, 19 divided by 8. Okay? Now, you can check this. Let's check it. Now, the way I would do this, since this is a fraction, I would go ahead and use a calculator. So take your calculator out. And here's how you check. So remember, we've checked equations before. Always go back to the original. Always go back to the original. Okay? All right, so I'm going to write the equation over. 2/3 times x minus 5/6 equals 3/4. All right, so remember, whenever you're checking, where we see the variable, you're going to substitute 19/8. So I have 2/3 times, and I'm going to go ahead and put that in parentheses, 19 divided by 8 minus 5/6 equals 3/4. Okay? All right, now, here's something I got to remind you about. Okay, so just remember, when using your calculator, remember this right here stands for negative. This right here stands for subtractions. All right, so you gotta remember things like this. All right, now notice what we have here. We have 2 divided by 3 times, and I'm gonna put this in parentheses, although you didn't have to in this case, but I'm just go ahead and put it in parentheses, times 19 divided by 8. Close the parentheses, subtract 5/6, so minus 5 divided by 6, and press equal. And hopefully we'll get 3/4, right? All right, press equal. And what do you remember about 0.75? 75 hundredths. That is 3/4. All right. And if you didn't know that, then ask yourself, well, what is 3 divided by 4? 3 divided by 4 equal 0.75. All right. So this is our solution. Okay? All right, so that was number 1. Let's look at number 2. All right, suppose we had x minus 4 divided by 4 plus x divided by 3 equals 6. Okay, so again, this rational equation, so I have a rational equation, and my denominators are monomials. So that's the easy kind. Okay, so what's the LCD? What's the smallest number that 4 3 and this is 1 will go into? Well, 12. All right, so the LCD is 12. Now remember, so step one is to find the LCD, okay, which I did. Step 2 then is to multiply both sides by the LCD. Okay, so notice though, remember the parentheses. We needed parentheses here. So notice, how many terms do you see? How many fractions do you see on this side? You see 1, 2, and on this side you only see 1. So I need to put this in parentheses. That's important. Okay, so we get x minus 4 divided by 4 plus x divided by 3 equal 6. Okay? All right, now, remember the LCD is 12, right? Okay, so I'm going to say times 12 times 12. All right, now what is the next step? So multiply both sides by the LCD, and then I guess step 3, let's go ahead and say solve the equation. All right, so now we're going to solve the equation. So we're going to solve the equation based on what we know how to solve equations. So I have parentheses, so I'm going to distribute, right? That's your next step, distribute. So I get 12 times x minus 4 divided by 4 plus 12 times x divided by 3 equal, and then 6 times 12. Let's just go ahead and figure out what that is. So 6 times 12 is 72. Now I'm going to go ahead and reduce next. So we've got to solve this equation, so let's reduce. Now remember, the whole point of multiplying by the LCD is to make these a factor of 1. And now I can do that. 4 into 4 is 1. 4 into 12 is 3. 3 into 3 is 1. 3 into 12 is 4. You see what I did? Okay? All right, now here's where you got to be careful next. This one here. If you're not careful, this is what you're going to say. And I'm going to go ahead and put this in another sheet of paper. This is what you're going to say. You're going to say this. You're going to say, all right, well, that says 3 times x minus 4, so 3 times x is 3x, and you're going to say 3x minus 4. That's what you're going to say this is. Well, it's not. That is not true. Because remember, all of this is being multiplied by 3. So what you need to do next, whenever you have your numerator being a binomial or greater, like a binomial or trinomial or 4 terms, whatever it may be, if it's not a monomial, put in parentheses. Put in parentheses. And so this is what we have now. We have 3 times x minus 4 plus, now 4 times x. You see, I didn't have to put this in parentheses because that was a monomial. The numerator is a monomial. And I know that 4 times x is 4x equal 72. Now let's go ahead and use the distributive property again. So 3x, 3 times 4 is negative 12. 3 times negative 4 is negative 12. Plus 4x equal 72. Combining like terms, remember I have a linear equation. This is a linear equation right here. That's linear. So I get 7x minus 12 equals 72. Adding 12 to both sides, I get, combining like terms, I get 7x equal 84. And then dividing both sides by 7, I get x to be 12. I get x to be 12. Okay? All right, now notice, you got to be careful because anywhere along the way you could have messed up. All right, so some of you, if you're not careful, you could mess up going from here to here. So you would say this would have been 12x minus 4 when you know now it's supposed to be 3x minus 4. It should be 3x minus 12. Okay, so remember, go back as you're practicing with the worksheet. Go back and make sure you follow this and you look at these videos again. Okay. Now, let's go ahead and check this. Now remember, on a test, you're not going to have time to check um, the solutions where you have monomial factors, where the monomial factors are constants. All right. So now in a little while, though, you are going to see that there are going to be situations where you will need to check. It's necessary that you check, but in this case, it wasn't. But as a general rule, what I would do is whenever you have irrational equations, just go ahead and check. Go ahead and check. Now, in a little while, you're going to see that there are situations where you do have to check, and you're going to see what we mean by that. All right, but let's check this. Check x equal 12. So always back to the original, right? Always go back to the original equation. So I'm going to write the original equation over x minus 4 divided by 4 plus x divided by 3 equals 6. All right, so wherever we see the variable x, I'm going to substitute 12. So 12 minus 4 divided by 4 plus 12 divided by 3 equals 6. Well, 12 minus 4 is 8, right? So I get 8 divided by 4. And what's 8 divided by 4? Well, that's 2. 12 divided by 3 is what? Well, that's 4. And is 2 plus 4 equal to 6? Yep. So x equals 12 is a solution. Okay? All right. So, the other thing I wanted to mention was this. Here's another common mistake people make, and I need to mention this. So you see right here where we had 12 times x minus 4 divided by 4 plus x divided by 3. I just want to look at this side for a moment. Here's what some people do, and this is incorrect. So they'll go ahead and they will reduce. They'll say, oh, 4 into 4 is 1, 4 into 12 is 3, and then distribute the 3. Okay, and that's incorrect. Because look what happens. When I do that, I get 3 times x minus 4 plus 3 times x over 3. That's what you get. And then when I distribute, I get 3x minus 12 plus, and that's x, because that's 1, and so that's x. Okay? But look, go back over here. I'm going to go ahead and fold this. Go back over here and see where the error is. Right here. What's wrong? You might say, well, that's correct, but look at this. That's the one that's incorrect. So the point is this. You're supposed to distribute a 12, right? I'm sorry, a 12, right? And so when I distribute the 12, notice right here, that was supposed to be 12 times x over 3 instead of 3 times x over 3. So the point being this, do not reduce like this and then distribute, because that's not true. That is not mathematically correct. Okay? So that is a common mistake. So don't do that. You will eventually do all this work for nothing, because the rest of this would be incorrect. Now, if you go back and you check, you'll see that, hey, something's wrong. It's not working out. This side does not equal 6. All right, and then you realize I made a mistake somewhere, and you have to go back and figure out where that mistake is. All right, so you have to distribute first. Distribute first, and then reduce. Do not reduce and then distribute. That's mathematically incorrect. All right, let's do number 3. Number 3, let's suppose in number 3 we had this. We had 1, let's say 3/5. Let's do that one first. 3/5 plus 1 over x equal 2/3. All right, so 3/5 plus 1 over x equal 2/3. Okay, now notice it's still the easy kind, except in numbers 1 and 2, my denominators were constants. So notice that's a constant, but that's a variable expression. But they're all still monomials, right? A monomial. So we got to find the LCD. So in the previous lesson, you learned how to find LCDs. So what's the smallest? Remember, the smallest expression that 5x and 3 will go into? Well, first of all, let's deal with the 5 and 3. What's the smallest number that 5 and 3 goes into evenly? 15, right? All right, so I'm going to do 15. But if I want this to be a 1, remember you always want these denominators at some point to be a 1. You want to clear those denominators. So will 5 go into 15? Yes. Will 3 go into 15? Yes. Will x go into 15? No. It won't. What's missing? I'm missing the x. So if I want to make this a 1, I need this to have a factor of x. See, LCD is 15x. So 5x and 3 will go into 15x evenly. All right, so that's your LCD. All right, remember step 1 is to multiply both sides by the LCD. So I need this in parentheses since I have two fractions. So 3/5 plus 1 divided by x equals 2/3. So now I'm going to say 15x, 15x. Okay? All right, now once you do that, that will be your first step. You all need to write this as your first step. So that way your chances of making an error will decrease if you do it step by step. Okay? All right, what's the next step? Based on the previous two examples, what do you think the next step is? All right, if you said the distributive property, yes. Now, is it okay for me to reduce the 5 and the 15 first and then distribute? No. Very good. No, you have to distribute first. Okay, so here we go. So this will be what you would write next. You would write, all right, so that's going to be 15x times 3/5 plus 15x times 1 divided by x, right? Equal, and I'm going to go ahead and just rewrite this over. 2/3 times 15x. All right, so that's where I'm at. Okay, now what I'm going to do next is I'm going to rewrite this again because I don't want to reduce now over this because it'll look a little messy. So I'm going to leave this alone. I'm just going to go ahead and rewrite this over, and let's see what we get. I'm just going to go ahead and rewrite this over. All right, now here we go. All right, now listen carefully to this. So I'm going to say, and hopefully it won't bleed too much, I'm going to say, remember the whole point of multiplying by the LCD is to make these what denominators? 1. Make those 1s, factors of 1. Okay, 5 into 5 is 1, right? 5 into 15 is what? 3. Good, so that's a 1 now. Let's go over here. X into x is 1. X into x is 1, right? Okay. 3 into 3 is 1. 3 into 15 is 5. So that's where I'm at. All right? So the whole point of multiplying every term by your least common denominator is to make these denominators 1s, factors of 1. All right, now let's go and multiply what we have. Now notice I have 3 times x times 3. 3 times x times 3 is 9x. So that's what this is right here. Plus 15 times 1 is 15. So that is 15. Equal 2 times 5 times x is 10x. Okay? All right, so that's where I'm at. All right, now, what kind of equation do I have here? This is a linear equation, right? So let's go ahead and bring the variables to one side, constants to the other. I'm going to go ahead and bring the variables to the right. So I'm going to subtract 9x from both sides, just like this. Combine like terms. I get 15 equals x, right? And I already have x by itself. Okay, so my solution, let's check and see if this is correct. So it looks like it's correct. Now I'm going to have to go back and talk about something else in a little while. But I just wanted to do this without talking about another important part of this one. So let's go ahead and check this. So let's check x equal 15. All right, check x equal 15. So where do you go? Where do you go to check x equal 15? Always go back to the original. So 3/5 plus 1 divided by x equals 2/3. All right, so let's see what we have. Use your calculator. 3 divided by 5 plus 1 divided by, oops, let me go ahead and write 3 divided by 5 plus 1 divided by 15, and I want to see if that's going to equal 2/3, right? 2/3, 2/3, oops, 2/3. So what 3 divided by 15 plus 1 divided by 15 equals 0.666 repeating, that's 2/3, isn't it? So 15 is correct. That's my solution. All right, now there's something else I got to tell you. All right, so listen carefully to this. And this is true for all rational equations. All rational equations. Now listen carefully, so because we had to do it in here and I did not, because I just wanted to go back and just kind of do this like we did 1 and 2. Now I have to come back and talk about something. Okay, do you remember in a previous lesson when we first started talking about rational expressions, we found that the domain of, let's say, x plus 1 divided by x plus 2 of this rational expression. And so remember, the domain of a rational expression would be all real numbers except those that make the denominator 0, right? Because remember, a rational expression is undefined when the denominator is 0. Rational expression, because we cannot divide by 0. Rational expression is undefined when the denominator equals 0. So if I go here and you could look at it and tell me what makes it 0, but let's suppose you did not. All you do is set that equal to 0. So x plus 2 equals 0. And when I solve this linear equation, I get x to be negative 2. So I remember we also call this a restriction. Remember that word? Restriction? So I found the restriction. So x cannot equal, I can't use x equal negative 2 into this. And so remember the next thing we did was and you were asked to put this in interval notation. But then I'm going to go back now and talk about another way you can write this mathematically. But if they ask you to put this in interval notation, you would just say, and remember we put this in the number line, and then you would say negative infinity to negative 2, union, and then negative 2 to infinity. All right? Now, mathematically, you could also say this, the domain, so that's one way. The other way is to say, in set notation, in a math lab, they may ask you to write it like this, but you would say the set of x's such that x does not equal negative 2. All right? Now, okay, so that's your domain. So your restriction is that x cannot equal negative 2. So the domain as an interval notation means this. So all real numbers except negative 2. As set notation, you just say set of x's such that x does not equal negative 2. All right? Now, let's go back to this example we're looking at now. All right, let me find it. Here we go. Will this denominator ever be 0? Yes or no? No, because it says it's always what? 5. That's a constant. Will this denominator ever be 0? Nope. It's a constant. It's always going to be 3. Will this denominator ever be 0? Yes. When what? When x is 0, right? So my restriction, and all you do here is just say this. Your restriction is that x cannot equal 0. All right, so you figure out what makes this, the denominators that have variables in it, you got to ask yourself, what makes it 0? Well, this is 0 when x is 0. So your restriction, you got to say this. You have to say this now. Restriction is that x cannot equal 0. So you may ask, well, why in number 1 and number 2 you didn't do that? We didn't talk about restrictions in numbers 1 and number 2. That's because when we did number 1 and 2, were any of these denominators variable expressions? Did any of these denominators contain variables? No. This is always going to be a 3. This denominator will always be a 6. This denominator will always be a 4. And number 2, if I can find it, in number 2, if you go back to number 2, ask yourself the same thing. Will this ever be 0? No, it's always 4. Will this ever be 0? No, it's always 3. Will this denominator ever be 0? No, it's always 1. Okay? All right, so it's only, you find the restrictions only when the rational equation has a denominator with variables in it. Okay? All right, and then there's a reason for that, because when you solve this equation, you must always check and see, first of all, is it a restriction? So is 15 0? Nope. 15 is not 0. So I can use it. All right, now let's look at number 4. Number 4. Suppose in number 4, I have this. Number 4. All right, let me find the problem I wanted to use. All right, so number 4, let's suppose we had this. That's not the page. All right, number 4. We have 1 plus 3 divided by x equals 28 divided by x squared. Okay? All right, so that's my equation. All right, now listen carefully. First of all, is this an equation? First of all, you notice that this is rational. Okay, so that's a rational equation. But look at the denominators. Are these monomials? Yeah, those are monomials. You don't. This is not a binomial. This is not a binomial. This is not a trinomial. This is not a trinomial. They're monomials. So that's the easy kind. All right, let's find the LCD. Step 1, find the LCD. Okay. This is a 1, right? 1 over 1. Y'all agree? Okay, so what's the smallest expression that 1, x, and x squared go into? If you said x, that's not true, because remember we talked about that. So in a previous lesson. So, and the reason it's not x, because if you look at x squared, how many factors of x do you see here? There are 2. So how many do you need here? You need 2. So you need x squared. All right, so that's your smallest. That is the smallest expression that 1, x, and x squared go into evenly. So that's your LCD. All right, now remember the next thing is to multiply both sides by the LCD. So I need parentheses around this one. So 1 plus 3 divided by x equals 28 divided by x squared. So I'm going to say times x squared times x squared. Okay? All right. Now before I go on, let's look at restrictions. That should have been the first thing we should have done after we found the LCD. All right. Now remember, that's monomials right now. So in the next lesson, in part 2, we're going to see where our denominators are no longer monomials. So what do we do then? So restrictions. X cannot equal what? Well, what is this denominator right here ever going to be 0? No, it's always going to be 1. When is this 0? When x is 0. When is this 0? Again, when x is 0. Because what's 0 times 0? 0. All right, so the only restriction is 0. Okay? All right. So if I do all of this and I get 0 as one of my solutions, then we got to say something. All right, now what's the next step? Once I multiply both sides by the LCD, what's the next step? Well, I got to distribute. So I get x times 1 is x squared, and then I'm going to say plus x squared times 3 divided by x, right? X squared times 3 divided by x equals, and then we just go ahead and rewrite this over, 28 over x squared times x squared. Although most of you would have seen that as just 28, right? Because these divide out evenly, 28. All right, the next step is to reduce as much as possible. So I'm going to go ahead and rewrite this over. So I get this. I'm just rewriting it over. And now after I do that, I'm going to go ahead and reduce. Okay, I'm going to do this one first. X squared into x squared is 1. X squared into x squared is 1. And it kind of makes sense because what's x squared divided by itself? 1, right? X squared divided by itself is 1. Let's look at this. So this is x squared divided by x, correct? X squared divided by x. Well, remember, x squared divided by x means x times x divided by x. You'll agree that x squared is x times x, right? Okay, now let's reduce. X and x is 1. X and x is 1. You're left with x. So, what meaning this? X and x is 1. And how many factors do you have here? 2. You're only reducing 1. So how many should be left? Just 1. Okay? All right. Now, so I get x squared plus what's x times 3? 3x equal what's 28 times 1? 28. Now, in all of the 3 examples we did earlier, what kind of equation did you end up with at some point? You ended up with a linear equation, right? Look at this though. What kind of equation is this? It is quadratic. So that's a quadratic equation. All right. Now remember, we said earlier that in this part of the course, the quadratic equation will be factorable. But remember, in order to solve this quadratic equation by factoring, you got to put it in standard form. So meaning that you have to have 0 on this side. So I'm going to subtract 28 from both sides. And so I get x squared plus 3x minus 28 equal 0. And now let's factor. So when I factor this and the 2 binomials, I'm going to get xx, 7 and 4. This needs to be positive. This needs to be negative. And always check yourself. X times x is x squared. The outer is a negative 4x. The inner is 7x. When I add 7x and negative 4x, I get 3x. And then 7 times negative 4 is negative 28. All right, now remember that point when you have 2 factors, in this case, whose product is 0. What property did you use next? Yeah, so the 0 factor property. That's correct. And so the 0 factor property says that if you have 2 or more factors whose product is 0, then either the factor A is 0 or the factor B is 0. So meaning in this case, either x plus 7 is 0 or x minus 4 is 0. And notice I went from a quadratic equation to 2 linear equations. And so here x equal negative 7 and x equal 4. All right, now at this point, this is where you got to look at your restrictions. What's the only number that makes this equation or any of those fractions undefined? 0. Or any of these zeros? Nope. So those are your solutions. So my solutions are, x equal negative 7 and x equal 4. All right, and we can check it. Let's go ahead and check this. Let's check both of them. Let's check. X equal negative 7 first. Okay, now where do you go? You go to the original. 1 plus 3 divided by x equal 28 divided by x squared. That's where you go. And wherever you see the variable, you're going to substitute negative 7. So I have 1 plus 3 divided by negative 7 equal 28 divided by, now make sure you put that in parentheses, negative 7 squared. Okay? All right. Now, let's check this. Now, you might say, well, why did you put it in parentheses? Because if you did not, and you use your calculator would have given you a negative 49. And it's not a negative 49 because a negative 7 times itself is a positive 49. That's why it was important. So if you wanted to, you could have put that in parentheses here as well. All right, so just be on the safe side. Whenever you substitute, just put parentheses around it because some of you are not going to remember that this needed to be in parentheses. And your calculator would have given you a negative 49 instead of a positive 49. Okay? All right, so let's see what we have. Okay, so now you're going to say 1 plus 3 divided, let me do this over. 1 plus 3 divided by, in parentheses, negative 7. Make sure you use the negative button. All right, and press equal, and this is what you get. So you get 0.571. All right, so keep that in mind. You get 0.571. So that's, I'm going to put that here. So that's approximately equal to 0.571, right? Okay, let's look at the other one. Let's check this side. 28 divided by, in parentheses, negative 7 squared. See, 28 divided by negative 7 squared. Press equal. Get the same thing? Yep, you sure do. So that's correct. Do the same thing with 4. So let's check 4. So if I check x equal 4, let's see what we get. 1 plus 3 divided by 4. Now, since 4 is positive, I'm going to go ahead and not put in parentheses. And I want to see that's going to equal 28 divided by 4 squared, right? But you still could. It's no big deal if you did or did not, okay? So if you put in parentheses, just make sure you put parentheses in your calculator. 1 plus 3 divided by, in parentheses, 4, close the parentheses, press equal, 1.75. So keep that in mind. 28 divided by, parentheses, 4, close the parentheses and square that, and you get 1.75. All right, so x equal 4 is correct as well. So those are your solutions. Okay? All right, now that should be enough to help you. Well, actually, let's do one more. I just want to do one more because you may see this on one of your My Math Lab examples or a worksheet. All right, so let's get this one. All right, let's suppose we had, and this will be number 5. All right, suppose we had 14 divided by, let's say, 3x. 14 divided by 3x minus, let's say this is 2/5 equal 3 divided by 2x. Okay? So 14 divided by 3x minus 2/5 equals 3 divided by 2x. All right, I want you to notice this. First of all, this is a rational equation. Okay, that's a rational equation. Secondly, I want you to notice the denominators. Those are monomials. Or do you see any binomials or trinomials or anything like that? Nope. You see monomials. That's the easy kind. So let's find the LCD. What do you think the LCD is? What's the smallest expression that 3x, 5, and 2x will go into? All right, so what I would do first is look at the numbers, 3, 5, and 2. What's the smallest number that 3, 5, and 2 go into? All right, so if you said 15, you're incorrect. Because it's not 15, so don't forget about the 2. Will 2 go into 15 evenly? Nope, it will not. So if you're having a little difficulty, remember what we said. Always use the largest that you see and look at the multiples. 5 times 2 is 10. 2 goes into 10, but 3 does not. 5 times 3 is 15. 3 goes into 15, but 2 does not. 5 times 4 is 20. 2 goes into 20, 3 does not. 5 times 5 is 25. None of these go into 25 evenly except the 5. And then 5 times 6 is 30. Does 3 go into 30? Does 5 go into 30? Does 2 go into 30 evenly? Yep. So what do you think the LCD is for your numbers, 3, 5, and 2? 30. Now, do I need an x? Yes, you do. Because that's the only way I can get a denominator 1, because I got to multiply by x right here to clear this. Okay, same thing here. Now I'm going to ask you, if this was an x squared right here, would it be 30x or 30x squared? It would be 30x squared. That would be your LCD. Okay, so the LCD is 30x. Now remember, the next step is to multiply both sides by the LCD. And first of all, let's go ahead and, since I do have variables in the denominator, let's find the restriction. What can't x be? So x cannot equal what? What makes it 0? 3x equals 0 when what? When x is 0. 2x equals 0 when what? When x is 0. Because 2 times 0 is 0. 3 times 0 is 0. Why didn't I even use this one? Because this is never going to be 0. Because there's no variable there. This is always going to be what number? 5. It's always going to be 5. So the only restriction, even though you saw two denominators with a variable in it, the only restriction is that x cannot be what? 0. Okay, now let's go ahead and multiply both sides by the LCDs. I'm going to put this in parentheses. 14 divided by 3x minus 2/5 equal 3 divided by 2x. So at this point, this is where you say, I'm going to multiply this by 30x, and multiply this by 30x. Okay? So that's the first thing all of you are going to show. Then all of you are going to say this. All right, now I've got to get rid of the parentheses, so I'm going to use the distributive property. So don't reduce first. You got to distribute first. So I get 30x times 14 divided by 3x minus 30x times 2/5 equals 3 divided by 2x times 30x. All right. Now I'm going to go ahead and rewrite this over, because at this point, this way you would reduce. I'm just go ahead and rewrite this over, though. Now remember, guys, the whole reason for multiplying by the LCD is to make these what factors down here. What do you want these to be? And remember, you want these to be 1. You want these to be factors of 1. So that's a whole reason for multiplying by the LCD. So you can clear your fractions. Okay, now we're going to reduce. So 3 into 3 is 1. 3 into 30 is 10. X into x is 1. X into x is 1. Okay? Go here. 5 into 5 is 1. 5 into 30 is 6. So remember, the whole point of multiplying by the LCD is to get these to be 1s. And we're doing it now. 2 into 2 is 1. 2 into 30 is 15. X and x is 1. X and x is 1. Okay? All right. So now the next step is to multiply these factors. So 10 times 1 times 14 is 140. That's what this is. Minus 6 times x times 2 is 12x. Equal 3 times 15 is 45. 3 times 15 times 1 is 45. So notice I went from a rational equation to a linear equation. Okay? So let's solve this linear equation. I'm going to go ahead and subtract 140 from both sides. And so when I combine like terms, now be careful, this is a negative 12x. You got to say negative 12x equal, and then 45 minus 140 is a negative 95, right? Okay. Then dividing both sides by negative 12, I get x to be, now remember, a negative divided by negative is a positive, so get 95 over 12. Now, you cannot reduce this, so I just want you to notice that 95 divided by 12 is this rational number that doesn't terminate, okay? So you have this rational number that doesn't terminate. All right, so there's your solution, and leave it as an improper fraction. But you gotta check though, and in the next lesson you're gonna see that we're gonna use a different word. We're gonna use an additional word in the next lesson. But you gotta check to see if that was a restriction. So is your solution 0? Nope. So we're okay so far. You just gotta make sure you didn't make an error. Because you see, there's a lot of places you could have made an error, right? That's a lot of work. Like, geez, that's too much work. But you got to go through that process. Okay, so always go back where? To check your solution, where do you go? Well, you go to the original equation. So I have 14 divided by 3, I'm going to put parentheses, times 95 divided by 12, minus 2/5, and right here, and I want to see if that's going to equal to 3 divided by 2 times 95 divided by 12. Okay? All right, now, here's the situation. Here's the issue with the way this is written. I want you to look at this before we check. All right, now I'm gonna I made this example easy to where you can understand. Okay, so I have 8 divided by this product, right? 8 divided by this product. All right, now what is 4 times a half? Well, 4 times a half is 2. And what is 8 divided by 2? Well, 8 divided by 2 is 4. All agree? So this right here is equal to 4. It's actually equal to 4. But here's the problem when using the calculator, though. So this is going to be a calculator issue. And we got to figure out how to correct this. So if I do this is what some of you are going to say. Some of you are going to say, all right, I have 8 divided by, and then basically what you do is you just type in what you see, right? So 8 divided by 4 times, in parentheses, 1 divided by 2. Or you could have said 0.5. You get 1. So something's wrong because the answer is supposed to be a 4, but we get a 1. Here's the problem. Here's the problem. So remember, your calculator is only doing what you tell it to do. So you told your calculator, all right, I want you to take 8 divided by 4, right? That's what this says. So I'm going to take 8 divided by 4, and then once I divide by 4, then I want to multiply it by 1/2. That's what you told it to do. But the question is this the same thing as this? Is 8/4 being multiplied by 1/2, or is 4 being multiplied by 1/2? It is 4 that's supposed to be multiplying by 1/2. So writing like this is incorrect. So here's what I would tell you to do. Whenever you see something like this, where you have, let's say, a monomial being multiplied by, being divided by factors, a product of factors, what I would do is I would rewrite this as 8, and then I would say on your calculator divide by, and then put that in parentheses, 4 times, in parentheses, 1/2, just like this. Okay? All right, keep that in mind. Now let's go here. So we now know if you say 4 divided by 3 times 95 divided by 12, oops, in parentheses, 95 divided by 12, that this is not this. That is not this. Okay? All right, so here's what I would do. 14 divided by 14 divided by, in parentheses, 3 parentheses 95 divided by 12, close the parentheses here, and then close it here. So here's what you get. 14 divided by parentheses 3 times parentheses 95 divided by 12, close that parentheses, and then close that, press equal. And this is this right here is 0.589. But you got to subtract 2 fifths. So let's go ahead and do that. So subtract 2 divided by 5 equal, and so this left side is 0.189. Okay? 0.189. Now let's check and see what this is. Do the same thing. 3 divided by parentheses 2 times, in parentheses, 95 divided by 12, close the parentheses, close that, press equal, and you get the same thing. So those two sides are now equal. All right. So that one is a little bit more tricky to deal with because the way you enter your calculator is important. So make sure when you have a bunch of factors in the denominator, you put this whole denominator in parentheses. Okay? All right. So that's a long lesson on this part 1, but I think that these 5 problems were necessary to get you through a better understanding of how to solve rational equations. Now in part 2, you see how in part 1 all these were monomial factors? In part 2, you won't have monomial factors. They'll be some will be monomials, some will be binomials. So we got to look at how to determine the LCD and what our restrictions would then be. Now, in the next lesson, you're going to hear the word extraneous. So whenever you have restrictions, whenever you multiply both sides by a variable expression, meaning it has a variable in it, you could introduce false solutions. So that's why you have to check your solution to see if it's an extraneous root or not. Okay, so we're going to use those words in the next lesson.